Alright, a regular octagon is inscribed inside a circle as shown in the figure. The diagonals of the octagon create 8 congruent triangles. The diagonals intersect at the center of the circle. The height of any of the triangles is h, while the base is b. The sides of the triangles are located within the circle and are congruent, each with a length of r. Drawing the radii to each vertex of the octagon, we created 8 congruent triangles. We can find the area of the octagon by taking 8 times the base, the perimeter of the octagon, and multiplying it by h divided by 2. The blank of the octagon is close to the blank of the circle. Therefore, the value of h is very close to the value of r. Choose the term that correctly fills in both of the blanks in the previous sentence. Okay, well, 8 times the base would, since this is the base, and I took it 8 times, that would move me around the entire outside of the octagon, which is the perimeter. So that's where they made this connection with the perimeter of the octagon. And multiplying it by h divided by 2, they rearranged this formula, and they said, well, I could do 1/2 and times it by h first, and then multiply it by b. Well, if we did numerator to numerator, like, remember, you multiply across top and to the bottom, and anything can be written as a fraction over 1. So that's where they got h halves from, is they multiplied this 1/2 times h. So that's where they got this from. And they combined the 8 times our base right here. So they just rearranged this formula, which is completely legal with math and multiplication. So now it says the blank of the octagon is close to the blank of the circle. Therefore, the value of h is very close to the value of r. Okay, well, here's my context clue. The value of h is right here, our height. It's really close. It's just missing by this much right there. It's missing that gap from going clear to the edge of the circle by just a little bit. So now we are just going to compare what this is. So it could be the diameter of the octagon is close to the diameter of the circle. Diameters really only happen in circles because they go through this center point and not towards an octagon. So the radius of the octagon, there's not a radius for the octagon. The perimeter of the octagon, the perimeter would be this outside edge of the octagon, which is missing quite a bit from the circle on its perimeter right out here because the circle is arched, or the area. Now the area is closer than I would say the perimeter is because it's only missing these little pieces right here between the octagon's area and the circle's area. There's only this much of a difference. So the area of the octagon is really close to the area of the circle, so the value of h is very close to the value of r. And we kind of knew that by the context clue that h is really close to the edge. It's just missing by a little. So that's how I would go through and use context clues to break apart what this was saying and how to answer it.